Assalamualaikum. Today our group will presenting about top 10 games from 1980 to 2023. My group have 5 people, which is Adik Muslim, Zarul, Syed Nakib, Muhammad Aizat, and myself, Muhammad Danish Adam. So we will start from introduction. In recent years, video games have gained popularity as a form of entertainment, and the industry has seen phenomenal development and success. Since computer space, the first commercial video game was released in 1970, with new platforms and technology being unceasing offered. So the objective of the data set is data visualization is one of the steps of data science process, which states that after data has been collected, processed, and modeled, it must be visualized for conclusion to be made. Second objective is data visualization is important for almost every career. It can be used by teachers to display student test result, by computer scientists exploring advancement in artificial intelligence, which is AI, or by executive looking to share information with stakeholders. Number 3, data visualization is also an element of the broader data presentation architecture, which is DPA discipline, which aims to identify, locate, manipulate, format, and deliver data in the most efficient way possible. The last is data visualization also plays an important role in big data projects. As business accumulate massive collection of data during the early years of the big data trend, they need a way to get an overview of their data quickly and easily. Next is displaying table. For the first, what is the most popular game in each genre? To calculate the most popular game in each video genre, in the game we are going to use the following approach. First, we will convert the popularity series to a data frame with a single column named popularity containing the popularity values. Next, we will merge this data frame with the game data frame, which is DF, on the genre column. This adds a new popularity column to the game data containing the popularity values for each game. The third, then we group the merged data by the genres column using the group by method. This creates a group by object with one group for each unique value in the genres column. Lastly, we define a function named get_mouse_pop_game that takes a data frame containing data for a group of games as input and returns the title of the most popular game in that group. The function does this, getting the row with the highest value in the popularity column and retaining the value in its title column. 5. We apply this function to each group in the group by object using the apply method. This returns a new series object containing the title of the most popular game in each genre. This is the chart for top 10 popular video game genre. That's leading by adventure. This is the popularity of the different games. To calculate the popularity of different games from different genres, we are going to follow this step. For the first step is split the genres column values and create dummy variables representing each genre using panda get_dummies column method. Second is sum the occurrence of each genre and sort the values by descending order to get the most popular first. For the third, plot the top 10 most popular video games genre. This is how plot by average game rating by release year. We can see 1980 to 2020 in the graph. To analyze the change in the trend of games rating over time. Release date, we are going to use the rating and the release underscore years columns. The rating column is going to be our indicator of how successfully a game is, represented on the x-axis. The release underscore year is going to be our timeline or trend to see the change of the video games rating over time, represented on the y-axis. From 1980 through the 1990, the average rating of video games experienced significant fluctuation with a notable decline in the late 1980s. However, starting in the 2000s, the average rating has become more stable and consistent. This change over time could be due to advancement in technology and game design, involving consumer preference and increased competition. These factors have led to an overall increase in the quality of game and their average ratings. So this is the table for the level of engagement of players with games. We can see the Fruit Ninja Classic game have leading the game. And then to calculate the level of engagement of player with game, we are going to take the following approach. Firstly, we will remove the rows from the data frame that have a value of 0 in the active underscore players column. This is done to avoid division by 0 when calculating the average numbers of plays per active player. Second step is we will calculate the average number of plays per active player for each game by dividing the no underscore off underscore plays column by the active underscore players column. The result is rounded to the nearest integer and stored in a column named average underscore players underscore per underscore player. For the fourth, when sort the data by the average underscore players underscore per and underscore player column in the descending order to show the games with the highest average number of plays per active player of the top. Finally, we will display the top 5 games with the highest average number of plays per active player. So this is the graph for top 10 games with highest engagement. So 2.5 is correlation between backlogging rating and wishlist variables. This is a correlation heat map. From observing the correlation heat map, we can see that there's a strong correlation between backlogs and wishlist, and there's some correlation between rating and backlogs. For 2.5.1, the scatter plot reveals a strong correlation between the wishlist and backlogs variable. This is plausible because people who have added a game to their wishlist are likely to have access to it but may not have started playing it yet. This is the plot graph for correlation between wishlist backlogs. For 2.5.2, the correlation between the rating and backlogs variable appears to be positive. As the average number of backlog increase, so does the rating. This may be due to people gaining access to games with highest rating but not starting them. For 2.6 is algorithm. The dataset are in unsupervised learning under the category of clustering, a technique that is commonly used for exploratory data analysis and to identify patterns or groupings within data. It is to group games based on their genre, platform or release date. This could help us to identify trends or pattern in the popularity of certain types of games over time. So, we move to data pre-processing, method, reason and codes. Method and reason. The following data pre-processing method may be suitable for a dataset on popular video games on 1980 to 2023. First, data cleaning. For data cleaning, the process of addressing missing values, resolving discrepancies, and eliminating unnecessary information like duplicates or incomplete records. For the data normalization, it entails scaling the data in order to make sure that the range of all features is comparable. For instance, dividing the sales values by the dataset's highest possible sales figure can normalize the data. For the data encoding, the process of transforming category data into numerical data, machine learning algorithm may utilize it, using a games as a generous as a numeric value. For instance, for data discretization, is converting continuous data to discrete values is known as data discretization. Organizing real estate into discrete areas, for instance, can help to cut down the amount of distinct values. For the features engineering, the process of developing new features from already existing ones in order to increase the analysis precision. Making a feature that tells whether a game is a part of a well-known series is one example. For the dimensionality reduction, reducing the amount of features in the dataset while keeping the most crucial data is known as dimensionality reduction. Using principal component analysis, which is PCA, to determine the most important traits is one example. For lastly, outlier detection. Outlier detection is locating and eliminating of rectifying data points that divide noticeably from other data points. Talking out games with extremely high or low sales data that don't reflect the general trend, for instance. This is the code to perform data pre-processing. For the first is load dataset. Second, handle missing values. And then correct inconsistent data. For example, convert all genres to lowercase. And then remove irrelevant data. For example, remove duplicates. You can see that. And then scale the data. For example, normalize sales features. And then encode categorical data. For example, convert genre to numeric values. And then discretize continuous data. For example, group release dates by date. And then feature engineering. For example, create a feature that indicate whether a game is a part of a popular franchise. And then dimensionality reduction. For example, use PCA to identify the most significant features. And then outlier detection. For example, remove games with unusually high or low sales figures. So, we move to the fourth part, parameter tuning. In parameter tuning, we have four, which is explanation, codes, comparison, and conclusion. For explanation is, in this task, we will be working with an unsupervised learning data algorithm called k-means clustering, which is widely used in data science for segmenting data into different groups based on similarity. The data set that we'll be using contains information about the top 100 most popular video games of all time, including their name, platform, year of release, genre, publisher, and sales. And then I will show you the example to coding step by step. Step 1 is load the dataset. First, we need to load the dataset into our Python environment. We can use the pandas library to do this as follows. Example, we use import pandas spd. Step 2, pre-process that data. Before we can apply the k-means algorithm to our data, we need to pre-process in to ensure that it is in a suitable format. We can start by dropping any rows that contain missing values. Next, we can select the columns that we want to use for clustering. We will be using the year of release and global sales columns to cluster the video games based on the popularity. Step 3. Apply k-means clustering. Now we can apply the k-means algorithm to our pre-processed data using skip length k-means class. Here we have specified that we want to cluster the data into 3 groups and set the random state to 42 for reproducibility. For step 4 is evaluate the model performance. To evaluate the model performance of our model, we can calculate the inertia of the clusters, which is the sum of square distance of sample to their closest cluster center. Lower inertia, lowest values indicate better clustering performance. For the step 5 is fine-tune the model. We can fine-tune the k-means algorithm by adjusting its hyperparameters such as the number of clusters and the initialization method. For example, we can try increasing the number of clusters to see if it improves the clustering performance. We can also try different initialization methods such as k-means plus plus, which tends to converge faster than random initialization. For step 6 is comparison. Compare module performance. After fine-tuning the k-means algorithm, we can compare its performance before and after by calculating the initial values. We can see that increasing the number of clusters from 3 to 5 improve the clustering performance, and using the k-means plus plus initialization method further improve it. So we have to conclusion. For the conclusion is k-means clustering is a powerful unsupervised learning algorithm that can be used for various applications including market segmentation, image comparison, and anomaly detection. However, selecting the appropriate number of clusters and initialization method can be challenging, and fine-tuning the algorithm is often required to achieve optimal performance. With practice and experimentation, data scientists can leverage the power of k-means clustering to gain value insight from their data. Thank you. That's all from our group.